Hello students, today I am going to cover up producer consumer problem and its solution. How to achieve the synchronization in the producer consumer. So producer consumer problem is also known as the bounded buffer problem. The process shares a common fixed size buffer. The producer produces an item and puts it into the buffer, and consumer consumes an item from that buffer. So buffer is of the limited size. If the buffer is full, the producer will not produce any item, and if the buffer is empty, so consumer will not able to consume any of the item. So we can say if buffer is empty, consumer will go into the sleep. If buffer is full, the producer will go into the sleep. So this is the all discussion about the producer consumer problem. Since the buffer is of bounded size, limited size, so we have taken it as n and may have any value. If suppose that the value of n is 1, that means producer will produce one item and it is compulsory for the consumer to get activated and consume that item. Otherwise, the producer will always in the sleeping mode. So in case of one buffer size 1, the producer will produce and consumer will consume. This process will continue every time. While in case of buffer having size n, that may be n may be value have 10, so producer can produce simultaneously 10 items one by one, and the consumer can consume 10 items continuously. It has not to wait. So here is the consumer producer consumer problem. Suppose that producer, it will produce an item, while true it will continue to produce. It will check, it will generate an item. Suppose and this is the produce item is the code, so it will produce an item and it will hold into the variable that is the item. It will check for the count whether the buffer is full or not. If count is equal to n, that means buffer is full, so it will go into the sleep. Otherwise it will insert an item and increment the count value as 1. Similarly, if consumer will enter into the consumer code will get executed, so it want to consume the code. It will firstly check whether the buffer is empty or not. If count is equal to 0, so that means buffer is empty, so it will not remove an item. It will become in the infinite loop. Otherwise it will remove an item from the buffer and it will decrement the value of count, and then after consume that item. Everything is working fine until the producer code and consumer code executing one by one if there is no context switching. But when there is a context switching, this may lead to absurd result or incorrect result. Now, where it will be, as we have already seen in the process synchronization problem, the variable is stored at the memory location X. If we want to perform any action, it must bring up into the accumulator, and then after accumulator will get incremented, decremented, or multiplication, something like that one, whatever the operation we want to perform. And then after, the value of accumulator must be stored at the particular memory location. So this is the procedure. Similarly, if it want to decrement the value, so again it will accumulator will fetch the value of the memory location into the accumulator, and then after accumulator will be decremented as AC is equal to AC minus 1, and at the last the memory location will get updated by the latest value of the accumulator. Now When there is a operation, increment and decrement are performing by the any of the process. That means producer is incrementing and consumer is decrementing. If suppose that there is a switchover, if there is a switchover, then it will lead the incorrect result. As we have discussed, suppose that after performing the two values, that means let count is equal to 5, let count has the value 5, and two operation get executed, means it will fetch the value in the accumulator as 5. 5 is stored at the memory location X, so it will be copied into the accumulator, and now accumulator will increment its value, and before updating the value at that memory location, there is a switchover from producer process to the consumer process. Again, it will read the memory location value at X. So it will still found the value X of 5. So it will store the value 5 and it will decrement the value by 1. That means 4. And then after there is again switch overing. So it will store accumulator has the value at present 6. So it will update the value as 6 at that particular memory location, and then after there is a switch overing, so it will update the value as 4 at that memory location. So the answer should be 5 because producer had produced one item, so it will become 6, and then after consumer is consuming one item, so it should be 5 minus 1. 6 minus 1, that means 5. So answer will remain still 5, but here the answer is 4. So this is the one of the drawback of the producer consumer problem. So how can it be resolved? It can be resolved by the with the help of the semaphore. So we know that semaphore is a variable. It may be the binary variable. So that is a special case of the counting semaphore. So let us look in the next slide. Now, here I have considered buffer size as 5. We have to consider is binary boolean or the binary semaphore as S, and counting semaphore N, that counts the number of empty slots. Initially, it is assumed all slots are empty, and a counting semaphore full is equal to 0. When all slots are empty, that means no slot is full. So what will happen? So here producer will produce an item. Then after when producer produce and going to produce an item, it will in it will check for the empty slot. It will check for the empty slot whether there is any empty slot or not. So it will execute the wait. Wait wait condition basically used for decrement the value. Wait condition is basically used for decrement the value. So here empty slots are here the empty slots are defined by E, capital E, it is capital E. So E is equal to N. So empty slot will be reduced by 1 if there are value 5. So now it should be E should have initial value as 5. Now it will become 4. Then after wait S, when the producer is going to add an item, consumer should not, you should be note this point, consumers should not consume the item. Otherwise, there is an absurd result, incorrect result. So for that, to restrict a consumer to enter into the critical section, we are using here a binary semaphore. So initially binary semaphore has the value 1, it will decrease by 0. So let us see the example in the next slide. So here I am giving only the code. It will add an item, then after signal the semaphore, and then after signal the full. So how it will take place, let us see. Similarly, at the consumer end, it will wait for full, and then after wait for semaphore S, it will delete an item. Then after it will signal it, and at the last it will signal the empty. How it will take place? Let us see in the next slide. Here, here we have assumed n is equal to, we have considered as 5, semaphore value as 1, and full is equal to 0. Now, suppose that initially all slots are empty and consumer want to consume something. Can it consume? No, because all slots are empty. So what will happen? Consumer will come here and initially wait F. Wait. Wait F means it will check for the it will check wait is basically check for the whether the slot is empty or not. So wait F will be called. So what will be a wait F? Wait F, let it is a wait F, let for the time being wait F. Initially, what is the value of F? F has the value 0. So 0 is less than equal to 0. Condition is true. That means buffer is empty. So it cannot decrease it because buffer is empty. So it will be a busy waiting condition until there is not an item into the buffer the consumer cannot consume. I am again repeating, it will call the wait F. Wait F, F has the value 0, full has the value 0. So it will call F as F is less than equal to 0. So 0 is less than equal to 0. Condition will get true. True means it will be in the infinite loop, means there is no item in the buffer. Now, again, I am considering the another example. If suppose that buffer is full, can a producer can produce an item? So here, so producer is going to produce. It will check EF. If all slots are full, the empty slot, the empty slot will have the value 0. The empty slot will have the value 0. So it will check for the E. So empty slot, it will check for the E as it will here. So it will check for the E. E has the value 0 since all slots are full. So E will have the, so F will have, at the time F will have value 5, full is equal to 5, and E will have the value 0. So here the condition will be checked, E is less than equal to 0 or not. Yes, it is 0. This condition is true. 0 is less than equal to 0. So automatically it will goes into the infinite loop. So consumer cannot or producer cannot produce if the buffer is full. So two conditions we have checked, they are working fine. Now let us check for the more condition, that is a generalized condition. We have checked the extreme condition whether the buffer is full or empty. So we have checked only those conditions. Now we are taking the generalized condition. How will it works? So now suppose initially buffer is empty and producer want to produce something. That means E has the value 5 and F full have the value 0 and S has the value 1. Producer want to produce an item, producer, so it will call the E. It will check E. E is equal to 5. 5 is less than equal to 0. Condition get false. That means E will be decremented. Now it is going to add an item into the buffer. Uh, when it is going to add an item into the buffer, so consumer should not allow it to enter or use the item from the buffer or consume the item from the buffer. So here there is a law. We have to apply the law. So weight s has initial value as 1. 1 is less than equal to 0. Condition get false. So automatically it will set the value 0. Now it will add an item into the buffer. If suppose that while it is adding an item, the consumer comes, what will happen? Let us see. Consumer will check the value of f. F is equal to 0. Now I am taking it as a f. So here it will be treated as the f. So what will be the value of f? Let us see. F. It is f. F. Initial f has the value 0. Initially f has the value 0. So 0, it is also f. It is also f. So 0 is less than equal to 0. Here it cannot consume. Suppose that it is okay. Now producer will put an item into the buffer. That means this array that we have taken, and after it, it will add, it will signal now the producer can, or now the consumer can consume an item. So again, it will set the value as 1. It will set value as 1. After this, it will signal f. Signal f. Now, what is the f? That means f, signal f means it will increment the value of f is equal to 1. Now f is 1. Suppose that now after producing an item, consumer comes. It will again check the value of f. 1 is less than equal to 0. Condition get false. In that case, it will decrease a value. Now it is going to consume the item. Now it is going to consume an item. Now for consuming, before consuming, it will decrease the value of the semaphore so that producer cannot produce an item into that place. Now it has set it as a 0. If producer appears suddenly and it wants to produce an item, so it will again check the value of s. Now the s will become the value as 0. 0 is less than equal to 0. Condition will be true. It will be in the busy waiting. So producer now cannot produce an item at that place. So in the array, so in the bounded buffer, so producer has to wait until the consumer will not consume, because consumer is in the critical section. So now consumer will signal as after deleting an item. Consumer will signal as, now signal as means it will increment the value as 1 after deleting, and it will set the signal E empty. Empty, now empty slot signal, empty slot E, let it is a signal E, so it will be a signal E. So empty slot will be incremented by 1. Now the empty slot will be 5. So this is the procedure how the producer and consumer operation can take place, and producer can enter or producing an item, so consumer cannot consume it. If consumer is consuming an item, producer cannot produce it. So there is a exclusive lock. Basically, there is a shared lock. Both can apply. Both can apply at at a time, and one by one, not at the same time. So semaphore variable, a boolean variable we have taken so that one process can enter in the critical section at a time. So this was the solution of the producer consumer problem. that we have faced here. So during the updation, there is only one process is entering into the critical section. So this was all about from my side about the producer consumer problem. Thank you.